So we are given a table. So the question reads, students were given carbonates labeled V, W, X, Y. Then they were to heat and test for carbon 4 oxide. And they obtained the following results. So from V, before heating, it was white. After heating, it still remained white. And this shows a positive test for carbon 4 oxide. W was white. This one turned to yellow. And then this one shows also presence of carbon 4 oxide. We have X. It was white. It remained white. It showed no presence of carbon 4 oxide. Then we have the last one, Y, which was green before heating. Then it turned black. Then it showed presence of carbon 4 oxide. Then from that analysis, we are told which letters represent copper carbonate. Copper is characterized by either green or blue. So it depends which copper was to be witnessed. But in this case, what will guide us will be after the heating, the substances that will be formed. So if you heat copper carbonate, we expect it to, so this is copper carbonate. Then you heat, you expect to form copper 2 oxide, then plus CO. So this one is the one that will be guiding us, and after heating, it is black. So we can say copper carbonate will be of Y. It will be of Y. Then sodium carbonate, it remains, so most of the sodium salts are white throughout before decomposing, even after decomposing. So we shall check the one that is showing presence of carbon 4 oxide, and it is white all through. And then this one goes straight to V. You are taught to write an equation for the color change of carbonate Y from green to black after eating. And I think I have already written, but we can still rewrite it. So it is copper carbonate. It is in solid state. So after eating, you get a black copper 2 oxide, still a solid, plus carbon 4 oxide, like that. An element Z consists of isotopes of masses 10 and we have 1 with percentage composition or abundance of 18.7% and 81.3% respectively. Determine the relative atomic mass of Z. The relative atomic mass of Z. So for us to get RAM, then we shall pick the mass numbers of the individual isotopes of the elements times their respective percentage composition. We get their sum and then we divide by 100. From this side, we'll be getting 187 plus 81.3 divided by 100. Still, after the summing up, you get 268.3 divided by 100. So now this becomes 2.63. Or question 3. Use the table below to answer the questions that follow. You can see it. So we have element E, F, G, and H. We have the electron arrangements 2.2, 2.7, 2.8.1, 2.8.2. Then you can still look at their atomic radii and the ionic radius. Then from just the look of the table, you are asked which elements have similar chemical properties. And then you are supposed to respond with the supportive argument you are told to explain. So from the look of things, from the electron arrangements, we can only see element E and H have 2 electrons in their outermost electron energy levels. So we can pick them because they will share something in common. So we can say each E and H. They belong to group 2. And in group 2, we call them alkaline metal. alkaline earth metals. So E and H, so they are in group 2. So they will be sharing some chemical properties. B, which element is a non-metal? Then you are supposed to explain. So which one, from the look of things, we consider still the number of electrons in the outermost energy level. So we can exclude E, we can exclude G, and we can exclude H. Because from the look of things, these elements, for them to acquire stability, they will lose the outermost electrons. And this is happening to metals. So what remains will be F, and it will be the non-metal. So we can point F, can say it gains an electron to acquire stability. It gains an electron to acquire stability. So it is having 2.7. So for it to become an ion, then it will be 2.8. That will be a +1. Part C, you're told write an oxide for E. An oxide of E. So it will be E reacting with oxygen. So we know that this one is valency 2, and this one, from the electron arrangement, then it will also be valency 2. Then they switch and they will cancel out. So we shall be having EO as our oxide. Remember that the letters do not represent the actual symbols of the elements. So even if you are very sharp, super genius, never carry E for the number 4 in the elements. Why? These are just elements given letters, not the actual elements. Name the elements that belong to the same group and explain. To the same group. So from the look of things, which elements belong to the same group? Let me check the question again. The same group, okay. We are still going to have E and H. So they are in group 2. So we have E and H. They have 2 electrons in the outermost energy level. So Guess we are at which group? It is group 2. Then you can carry this question. Explain how the ionic radius of element named in D differ. So we are having E and H, and we are comparing the atomic radius. So what can we say? So the difference is as a result of the number of energy levels. So we can say H has more energy levels than E, which accounts for the difference. In size of ionic already. So we have said one has 2.8.2 and another one has 2.2. So when we cancel these ones, this one will remain with 1 energy level and this one will remain with 2 energy levels. That is why H will have larger ionic radii than E. The diagram below, we are told to study heat. Use it to answer the questions that follow. We have a combustion tube, we can say so. We have gas P, which is being produced. We have a mixture of copper 2 oxide and a carbon. State the observation made in the combustion tube. State so the moment you heat, then carbon will act as a reducing agent in this case. Then it is going to snatch away the oxygen from the copper 2 oxide. So naturally, the copper 2 oxide is black in color. Then it is going to turn to brown copper. So we can say the black copper 2 turns to brown copper metal. Write an equation that took place in the combustion tube. So it is copper 2 oxide. Then you're going to get copper metal plus carbon 4 oxide. So we expect our gas P to be the carbon 4 oxide. So now give one use of P. So this is, you can say, use of carbon 4 oxide. So it is used in making speak outs.
Is used as a fire extinguisher.
Used as a fire extinguisher. Another one.
Used as a refrigerating agent.
So it is used in preservation. Preservation of soft drinks. We have our question 5 over there. The diagram below shows charcoal stove with different regions, A, B, and C. Then we're told write an equation for the formation of the product in B. So at the middle, that is what we are asked. So the first thing you must know what was happening at region A. So in region A, there was complete combustion, and then we formed CO2, which is carbon 4 oxide. So in region B, it will be carbon 4 oxide, reacting with carbon, and we are saying the carbon will be reducing. So in this case, we are going to form carbon 2, carbon 2 oxide. Then now we are supposed to balance. So if you have 2 here, then it will be well balanced. How would one avoid the production of the product at B? And then you are told give a reason for your answer. For us to breach complete combustion, then we need to burn charcoal in sufficient supply of oxygen. Maybe upeleke jiko kule nje, kitu kama hiyo. And this brings the idea of why is it a risk for one to sleep in a house where we have some jiko like this one and it is burning. For those who take biology, they know it better. Diamond and graphite are allotropes of carbon. Then the first question is what is means by allotropes? What is mean by allotrope? These are different forms of a substance, different forms of a substance in the same physical state. How do they differ in their structure and the bonding? How do they define their structure and bonding? So we can start with the graphites. In graphites, Each carbon is bonded to three others. And they are my net is having some issues. And they are weak van der Waals forces between its layers. Then in diamonds, all the carbon 4 oxides, all the carbon 4, the carbon, sorry, because they are 4, I'm just going for carbon 4 something. All the 4 carbons are covalently bonded, making a rigid mass. That is why we have diamond to be very strong metal. We have this chart.
Andisha juu kidogo. Hivyo sasa.
we have this chart. Over here. So can go straight to the questions. You're asked, name the process. What is happening in this one? So that is question A. Then you are going to say that this is Solvay process. Then we have the second question. Name the substances labeled X and Y. X and Y. Where can you see them? This one. And where is Y? We have this. So our X will be carbon 4 oxide.
Trans Y is carbon 4 oxide.
Yes.
Yes.
You are saying X is what? So we have these parts where you're told just name. Do you think a person who will write CO2 like this will be awarded a mark? No,
No.
because you are told to name. So can I write and say X is carbon 4 oxide. Then Y is calcium hydroxide. You can see where our Y is. So from S, here we had some serious eating, and that is thermal decomposition. That is why we had to produce carbon 4 oxide. Then to produce Y, we add water plus now the calcium oxide so that we can produce calcium hydroxide. Name two substances being recycled in the process. So we can now write the recycled products. Recycled products. So we have one, water, even though it is not a product. We have carbon 4 oxide. And then we have ammonia. We have ammonia. The next part, I wish I could be able to share the part of the chat. Then we have another part who can respond. Anyway, with time, I'll be having such tech. Then you are told, name the process that takes place in S and in R. So from the S side, you can see we are going to eat calcium carbonate so that we can produce calcium oxide and carbon 4 oxide. So that process of eating is called thermodecomposition. Thermodecomposition. Then we have R. Let's check where R is. R is somewhere here. Ndio hii hapa. So you can see what is being brought in here to R. We have ammonium chloride and sodium hydrogen carbonate. So we know that this one is aqueous and this one is solid form. So at R, we are going to separate them. So how can you separate a solid from a liquid? You filtrate. But now the process will be filtration. So you filter and then the process will be filtration. Ukiandika filter is just the act, but we are asked about the process. Filtration will fit. I hope we are together at that point. So you can just write R will be filtration. Filtration. So these ones tumezipeleka huku. Give 2 uses of calcium chloride. 2 uses of calcium chloride. 2 uses of calcium chloride. Now this one, we can take it here. It is used in extraction of sodium metal. From Form 1, it is used as a drying agent. And then the rest, maybe I can just say, it is used in countries with which experience very low temperatures to aid in defrosting of ice. So at that moment, it will be acting like an impurity. And because it is highly deliquescent, then it is used in road construction because of its deliquescent property to minimize dust. Write equations for the reactions that take place in Q. Write the equations for the reaction that place in Q. And the other one is T. So what is happening in Q? We have the ammoniated brine, and then it's being mixed with carbon 4 oxide. You can see it here. So we are supposed to write that equation. So let me get some space. So ammoniated brine is just from a mix-up of ammonia gas with sodium chloride. Now we add water and the carbon 4 oxide so that we can get ammonium chloride, then sodium hydrogen carbonate, which is solid. The equation is well balanced. Ammoniacal brine. Sometimes you can write this one in two equations, and maybe I can show you from the secondary Kelby book 2. You can write in this form. The first equation will be ammonia this is ammonia plus the carbon 4 oxide plus water, you get ammonium hydrogen carbonate. Then now, this product will react with the sodium chloride so that you can get sodium hydrogen carbonate and ammonium chloride. So we are supposed to write this one, ammonium chloride, aqueous, like that. So if you split these two equations, you'll still be okay. If you write the general equation, IOTE, then you still be okay, and there will be no problem. So now let's look at the process taking place at T. Can always get back to the charts. So at T, we are having substance Y, which we said is calcium hydroxide. T. Just a moment. So after filtration, what we'll be getting here will be the ammonium chlorides. And then it will be meeting with the substance Y, which is now calcium hydroxide. And from this case, we are supposed to produce calcium chloride and ammonia gas. So that is the equation that this question is demanding us. So substance Y, which we said is calcium hydroxide, plus the ammonium chloride. I think, yeah, this one is supposed to be in solid state. Then you are supposed to produce calcium chloride, solid state, plus water, plus ammonia gas. So this equation is supposed to be balanced. So if you have 2 here, another 2 there, and 2 here, utanisamea maana sijatumia different shade, but let me just show it. So we are having these 2. We have another 2 here, and we have another 2 here. So it will be okay. State the importance of the liquid recycled in the process above. So the first thing you are supposed to identify which liquid is that, and the liquid is water. So what is the purpose of the water? To cool the carbonator. Because the reaction that takes place in the carbonator produces a lot of heat. So it is exothermic. Other than softening of hard water, give to others uses of sodium carbonate. Uses of sodium carbonate, manufacture of glass, we have manufacture of detergents, manufacture of bleaches, used in the paper industry. The grid below shows part of the periodic table. Use it to answer the question that follow. Remember, the letters do not represent the actual symbols. So here is the grid. Which of the elements has the highest or largest atomic radius? Then you are supposed to explain. Out of all the elements that you can see in the periodic table, which one has the largest atomic radius? So in this case, Q carries the response. So we have Q, and then you are supposed to explain. It is in group 1, and in period 1, 2, 3, 4. It is in period 4. So it has 4 energy levels. Why can't we compare with the rest? Because if you say it has 4 energy levels, then it is like you are comparing with P only. Then it is because we know that towards the right, the atomic radius just decreases automatically. Towards the right, the atomic radius decreases automatically. Identify the most reactive nonmetal, and you are supposed to explain. This must be from group 7. And it is U. This one, group 7. So it has the very high capacity of gaining electrons to acquire stability. It can gain electrons with ease to acquire stability. Give the electron configuration of elements S and element Q. We can start with element Q. Element Q is in group 1. So group 1, period 4. So 2.8.8.1. While S is in group 6 and group 6, period 2. So it will be 2.6. It will be 2.6. Compare the atomic radius of P and R. P and R, the atomic radii. Remember I said from the left towards the right, then the atomic radii is supposed to be decreasing. Then we are supposed to support that one. So P has larger atomic radius than R. Then why? An extra electron enters the same energy level, making the nuclear charge. To charge stronger. Across the period. So across the period, there will be a general decrease in the atomic radii because within the same energy level, there will be an automatic extra increase of 1 electron, and this one increases the net nuclear charge. Yet, given that the atomic mass of W is 40, write the composition of its nucleus. We are having W as at that point. So you can see it is in period 3 and in group 8. So you can say W in group 8, period 3. So its electron configuration will be 2.8.8. So what does this one bring us? It has a total of this is 16, 18 electrons. And then these will be the same as the number of protons. So we can get from the mass number of 40, we can get the number of neutrons. So 40 minus 18, you get 22 is equals to N. So we have protons to be 18 and neutrons to be 22. So if you have to draw the nucleus, then you shall say we have 18 protons and we have 22 neutrons, like that. Write the formula of the compound formed between P and S. P and S. So P is in group 1 and this one is in group 6. So P will have a valency of 1 and S will be having a valency of 2. So when they exchange their valencies, then we shall get P2S as the compound. Then we have R and T. We get back to the table. R in group 2, the same T in group 6. So it will be R in group 2, it is valence 2, and T in group 6, still valence 2. So they exchange their valences and you get RT. If the formula of one stable ion with an electron arrangement of 2.8, which is negatively charged, and another one is positively charged. Remember, we are extracting all these ones from the table. So the one that is supposed to be negatively charged is supposed to be from group 7. Supposed to be from group 7. And you can see we are only having U. So U will be like that. Then the positively stable ion with 2.8, then let's take from the metals. So in group 1, this one, which is P, is in period 3, meaning that the electron is 2.8.1. So it is the one that can only lose one electron to acquire 2.8. So we write P. P as positive. Give the formula of one stable ion with an electron arrangement of which is negative. I think we can also, let me check. We can also go for R, where it will lose 2 electrons and acquire 2.8. And then its symbol will be R2 positive because it will have lost 2 electrons. State a reason why iron is the cheapest metal in the market. If you look at many people, they have gone for iron. Even people are collecting the scrap metals, getting back to the manufacturing industry, and then it is brought back to the market. So the reason is the production costs is low. The production cost is low. You're told write down the composition equation on copper 2 nitrate. We said the nitrates, this one for copper 2 nitrate is going to decompose to form a metal oxide, a red-brown gas, which is nitrogen 4 oxide, and oxygen. So our copper 2 nitrate, under the action of it, you get copper oxide plus nitrogen 4 oxide plus oxygen gas. So in this case, we are going to balance it. We place 2 here, 2 here. The number of nitrogens becomes 4, and the oxygens, we have 2 plus 8, that is 10, 12. Then we have 6 times 2, 12. So the equation becomes balanced. Name the particles present in the nucleus of an atom. This one is always the protons and neutrons. The electrons will be in the energy shells, like that. Explain the change in mass expected when the flowing substances are heated in an open crucible. So in this case, we expect recombining and we expect decomposition. So in copper, there will be an increase in mass. And the reason is because it combines with oxygen to form copper 2 oxide. So the addition of the oxide will increase the mass. Then in copper 2 nitrate, the mass decreases. Because it decomposes to form gaseous products, that is nitrogen 4 oxide and oxygen, which will escape into the atmosphere. Remember, we are talking of an open crucible. The table below shows pH values of solutions A, B, C, and D. And then you are asked, identify a solution which is strongly acidic. Strongly acidic. And this goes straight to A. Strongly basic, that goes to B. Which solutions would react with lead-2 oxide? And then you are told, explain. With lead-2 oxide, we still have A and B. And the reason for this one is because lead-2 oxide is amphoteric. So lead-2 oxide is amphoteric. It can show both acidic and the basic properties. In an experiment, a certain volume of air was repeatedly passed between 2 syringes overheated zinc powder as shown. The same experiment was repeated using magnesium tannings instead of zinc powder. In which of the two experiments was the overall change in volume greater? And then you are supposed to explain. We know that magnesium reacts with both oxygen and nitrogen to form magnesium oxide and magnesium nitride respectively. So we expect a greater change in the volume when we use magnesium. So when magnesium is used, so it reacts with both oxygen and nitrogen to form magnesium oxide and magnesium nitride respectively. We have a long way to go. Question 15. The atomic numbers of nitrogen oxygen and sodium are is given above. Is it above or below? And then you are told, write an electron arrangement of their ions. So we can start with the nitrate. Sorry, the nitrogen ion. Then we have the oxide. Then we can have the sodium. So the one for sodium will be 2.8. The one for oxygen will be 2.8 also. The one for nitrogen will also be 2.8. So nitrogen will acquire 3 electrons from 2.5 to have 2.8. And then oxygen will acquire 2 to have 2.8. Then we have sodium will lose 1 from 2.8.1 to 2.8. Arrange the 3 ions in increase in order of size. Give a reason for your answer. Then you're supposed to give your answer. Increase in order of the ions. Shall start with the sodium. Followed by oxygen. Followed by the nitrogen ion. And the reason is number of protons decrease to the right. Hence reducing the effective nuclear charge. Like that. So we are going to end with question 16. Phosphorus 3 chloride is having a melting point of -91, while that of magnesium chloride is +715. In terms of structure and bonding, explain the difference. So phosphorus 3 chloride has a simple molecular structure with weak van der Waals forces. While in magnesium chloride has giant ionic structure with strong ionic bonds. Thank you so much for the lesson. And share you subscribe to my channel, YouTube. Then may God bless you. Find it interactive for the open exams.